Hello everyone. Let us continue the solutions for UGC NET Electronic Science August 2024 question paper part 3. Question number 51. The magnetic field at the center of loop, that is H000, is given by. So let us assume I is a current carried by the circular loop of radius r, then loop radius A is pi r square, where r is the radius of circular loop. The magnetic field intensity at a point 00h is given by h is equal to ir square by 2 into r square plus h square whole power 3 by 2 into az cap. So az cap is the direction of magnetic field intensity. R is the radius here. R is the radius of circular loop, and 0 and the loop is lying at the center. So that is 0, 0, 0. So let us assume the loop is lying on xyz coordinates. Next, at the center of the loop, h is 0. The value of height h is 0 at the center of loop. So substituting h is equal to 0 in magnetic field intensity equation, then we will obtain h is equal to ir square by 2r square whole power 3 by 2, that is 2r cube 2r cube into az direction. So it is I, that is equal to I by 2r az whole cube. Next, in the question they have given the magnetic field B at the center of loop. Magnetic field, the relation between magnetic flux density and magnetic field intensity is B is equal to mu H. So replace with H is I by 2r az cap. So that is mu I by 2r az. So in the question they have asked magnetic field intensity H, correct option is 2. And magnetic flux density is mu times of I by 2r into az cap. So this is ampere per meter. The units for B is Tesla. So correct option is 2. Next question. Which of the following statements are correct about the basic transistor amplifier configuration? Let us see in BJT, bipolar junction transistor. So it has 3 terminals. So that is emitter, base, collector. So accordingly, we will have 3 configurations, that is common emitter configuration, common base configuration, common collector configuration. So let us see the comparison of common base, common emitter and common collector configurations. In common base configuration, input is emitter, output is collector. Similarly, in common emitter configuration, input is base, output is collector. In common collector configuration, input is base, output is emitter. The input resistance of common base is very low compared to all the 3. Input resistance of common collector is very high compared to remaining common base and common emitter. The voltage gain for common collector is less than or equal to 1. The current gain of common collector is less than or equal to 1. So only CE amplifier produces 180-degree phase shift. Rest common base and common collector produces 0-degree phase shift. So the DC current gain in common base is alpha, DC current gain in common emitter is given by beta, and the DC current gain in common collector configuration is given by gamma. So in the question, the voltage gain of common base amplifier is higher than the voltage gain of common collector amplifier. So voltage gain of common base is very high and the voltage gain of common collector is less than or equal to 1. So option 1 is correct. So the voltage gain of common collector is 1 and the voltage gain of common base amplifier is high. So this option is, the statement A is correct. Next, statement B, the common base amplifier has low input impedance and low current gain. Common base amplifier has low input impedance and low current gain. So current gain is less than or equal to 1. So statement B is also correct. Next, statement A correct, statement B correct. In common collector amplifier has high input impedance and low current gain. So common collector amplifier has high input impedance and high current gain. The current gain is high. So statement C is wrong. In statement D, the common collector amplifier has low input impedance, high current gain. Correct. So the common collector amplifier has low, statement E, the common collector amplifier has low input impedance and low current gain. So the input impedance of common collector amplifier is high. So it is high. So statement E is also wrong. The correct option is So the correct option is A. Statement A is correct, B is correct, and statement D is correct. Next question. So this question is related to Maxwell equations. So the Maxwell equations are Gauss law, Faraday's law, Ampere circular law, and isolated magnetic field does not exist. Let us see these equations in integral form and differential form. So Gauss law for electric field is del dot B is del dot D is rho V. So in integral form, it is written as closed surface integral of d bar dot ds bar is equal to open volume integral of rho v dv. So that is a charge enclosed. So this is a Gauss law for electric field, and del dot b is 0. Gauss law for magnetic field, del dot b is 0. In integral we can write as closed surface integral of b bar dot ds bar is 0. Next is Faraday's law. So del cross E is minus dou b bar by dt minus dou b bar by dou t. This is a Faraday's law in differential form. In integral form, it is written as closed line integral of E bar dot dl bar is equal to open surface integral of minus dou b bar by dou t into ds. Similarly, Ampere circular law, del cross H is equal to J bar conduction current density. In modified Ampere circular law, del cross H is equal to J bar plus dou d by dt. So it can also be written as in integral form line integral of closed line integral of h bar dot dl bar is equal to open surface integral of j bar plus dou d by dou t into ds. So these are the Maxwell equations in differential form and integral form. So Maxwell Gauss law for electric field, Gauss law for magnetic field, Faraday's law, and Ampere circular law. Next, where epsilon is permittivity, mu is permeability, H is magnetic field intensity, B is magnetic flux density, JC is a conduction current density, JD is displacement current density, E is electric field, D is a electric field, E is electric field intensity, B is the relation between B and H is B is equal to mu H, and the relation between D and E is D is equal to epsilon E. So D is epsilon E. Okay, as per the question, for option A, del cross H is equal to J bar plus dou d bar by dt. So it is 4. So they have given in terms of differential form and integral form. Next, del cross E is equal to minus dou b bar by dt. It is nothing but electromotive force around the closed loop is equal to the time derivative of magnetic displacement through the any surface bounded by the path. For B, it is option 1. For C, del dot D is equal to rho v. So it is option 2, integral form. Next, del dot B is 0. It is Gauss law for magnetic field. The net flux emerging through any closed surface is 0. So the correct option is 3. A is 4, B is 1, C is 2, and D is 3. Next question. The high frequency and high speed applications of MOSFET is controlled by capacitance charging time and transit time of the charge carriers. So correct option is 2. The high frequency and high speed issues of MOSFET are controlled by the capacitance charging time as well as transit time of the charge carriers. Next question. The following serial data is applied to a flip-flop as shown in the below. So this is given, it is JK flip-flop. For JK flip-flop, the input to JK flip-flop is from this output of say this gate, upper gate, and input to the K input to the JK flip-flop is the output of lower AND gate. So for upper AND gate, J1, J2 are the inputs. For lower AND gates, K1, K2 are the inputs. So from this, the resultant output is this one. So from these gates, the resultant output is 1001 0010. Given in the question, they are also given the initial state is 0. So in the initial state of the flip-flop is 0, and they also mention rightmost bit appear first. So this is a leftmost bit, sorry, this is a rightmost bit, and this is leftmost bit. This is not significant bit, but it is leftmost and rightmost in terms of series they have given. Next, so let us see some basics regarding JK flip-flop. So for JK flip-flop, if both inputs are 0 0, then output next state is same as previous state. If j input is 0 and k input is 1, the flip flop will reset. Next state is 0. If j input is 1 and k input is 0, the flip flop will set. So that means next state value is 1. If both inputs are 1 and 1, then flip flop gets toggled. This is a block diagram of JK flip flop. Block diagram of JK flip flop. So as per the question, for the inputs given, so this is one input j input and this is k input. For these inputs, what is the corresponding flip flop output? So initial state Qn is 0. For 0 0, for 0 0, so the flip flop remains in the same state. So previous state is 0 as per the question. For 0 1, it is 0. J is 0 means, so obviously the state of flip flop is reset. Next, k is 1 means the both are 1 1, so flip flop gets toggled. So 0 bar, it will become 1. For 0 0, again it remains in same state. For 0 0, remains in previous state. For 1 1, the output gets toggled. So this is the output. 0 triple 1, so this is output 0 triple 1 and 0000. So correct option is 1. Next question. So it is related to the breakdown electric field in the following materials. The materials given is gallium arsenide. So first, the definition of breakdown electric field is, it is defined as electric field strength required to cause dielectric breakdown in the material. If dielectric breakdown occurs in a material, the material loses its insulating properties. It will act as a conductor. So for gallium arsenide, the dielectric breakdown is 4 into 10 power 5 volt per centimeter. For silicon carbide, it is 2 to 3, maybe 2 into 10 power 6 or 3 into 10 power 6. It lies in the range of 2 to 3 into 10 power 6 volt per centimeter. For silicon nitride or silicon trisilicon tetranitride, it is 10 power 7. Silicon nitride or trisilicon tetranitride. For germanium, it is 10 power 5 volt per centimeter. For silicon, it is 3 into 10 power 5 volt per centimeter. So all these are in volt per centimeters. So the correct option is 2. So for gallium arsenide, it is 4 into 10 power 5. For silicon carbide, it is 2 to 3 into 10 power 6. For silicon nitride, it is 10 power 7. For germanium, it is 10 power 5. So correct option is 2. Next question. In a single mode optical fiber with attenuation of 0.25 dB per kilometer, the optical power in dBm 100 kilometer away from 0.1 milliwatt light source will be. So they have given the input power 0.1 milliwatt. So input power as 0.1 milliwatt and the fiber is single mode fiber. It is a single mode fiber with attenuation per kilometer is 0.25 dB per kilometer. 0.25 dB per kilometer and the total length of the fiber is 100 kilometers. Therefore total attenuation is 100 into 0.25 dB, that is 25 dB. This is the total attenuation in the fiber. Next, so we know that attenuation is given as input power ratio of input power to output power. So in attenuation means obviously input power is higher when compared to the output power. So the input power is 0.1 milliwatt. So this 0.1 milliwatt is equivalent to 10 power minus 4 watt. So that is minus 40 dB. In terms of dBm, its value is minus 10 dBm. So how to convert dB to dBm is addition of plus 30. So this is minus 10 dBm. So input is minus 10 dBm and attenuation is 25 dB. So that is 25 dB. So this is in dBm and this is in dB. The resultant is minus 35 dBm. So this is the output power. Output power in dBm. Power output in dBm. So the correct option is minus 35 dB. So it is option 4. Next question. So In T1 digital carrier, 24 voice channels of 64 kbps are sampled, quantized, and then encoded into a TDM pulse coded PCM signal, pulse code modulation signal. So for T1 carrier, the transmission capacity is 1.544 Mbps. So transmission capacity in megabits per second. So this T1 carrier has 24 voice channels, and each voice channel will have the capacity of 64 kbps. This 24 into 64 will become 1.544 into 10 power 6 bits per second. Similarly, for T2 carrier, it is nothing but 4 times of T1. So T2 is 4 times of T1. 4 into 1.544 Mbps is 4 into 1.544 Mbps. So its value is 6.312 megabits per second. So it consists of 96 voice channels. 24 into 4 is 96 voice channels, and each voice channel has a capacity of 64 kbps. Similarly, for T3 carrier, so T3 is 28 times of T1. So for 28 times of T1, the capacity is 44.736 Mbps. For T4 carrier, it is 168 times of T1 carrier. So that is 274.176 Mbps is the total capacity. So T3 carrier has 672 voice channels, and each voice channel has a capacity of 64 kbps. Similarly, T4 carrier has 104032 voice channels, of each voice channel has a capacity of 64 kbps. So this is related to T1 digital carrier system. So as per this, correct option is 2. So T1 carrier has 24 voice channel, and each voice channel has 64 kbps. T2 carrier has 96 voice channels, and each voice channel has a capacity of 64 kbps. T3 system has 672 voice channels, and each voice channel of 64 kbps. Similarly, T4 is 4032. So correct option is 2. Next question. For a single phase full wave firing pulse generator, using inverse cosine control principle, arrange the different sections of the circuit starting from AC input supply to the SCR of the gate. So first is 90-degree phase shift circuit, and the second one is isolating transformer, and third is level comparator, and the fourth block is clock pulse generator, and fifth is pulse output flip flop. So this level comparator, the transformer output is compared with the cosine timing wave. Clock pulse generator provide regular periodic pulse train. So for this, cosine wave must be generated before level comparison can occur, and the isolating transformer must precede the level comparator. So the purpose of this isolating transformer is to provide electrical isolation and potentially adjust the voltage level, and the comparator output is synchronized with the clock pulses processed by the flip-flop output to generate the precise firing pulses for the SCR gate. So that is, flip-flop generates final the final firing pulse. So the correct sequence for these blocks is, first is level comparator, and then isolating transformer, and isolating transformer. So first is C, 90-degree phase shift circuit to obtain the cosine timing wave, and second block is isolating transformer, and third is level comparator, and fourth is clock pulse generator, and finally flip flop. So this is the correct sequence. Correct option is 2. Next question. In K type chromel aluminum thermocouple, so first of all, they have given the temperature range for different types of thermocouples. So the definition of thermocouple is, it is a temperature transducer. Thermocouple is a temperature transducer that consists of two dissimilar metal wires joined at one end, called measuring end. That is a hot junction. The measuring end is hot junction, and other end wires are not joined and it is connected to the measurement junction, that is the reference junction. So the temperature range of thermocouple depends upon the thermocouple and metal wires used in the thermocouple. So this thermocouple works on the principle of Seebeck effect, that is voltage generator is proportional to temperature difference between the junctions. So for this question, K-type aluminum chromel, the temperature ranges from minus 150 to plus 1000 degrees centigrade, minus 200 to plus 1200 degrees centigrade. For B-type copper constant and thermocouple, so the option is 3, minus 150 to plus 350. For S-type platinum with 90% platinum and 10% rhodium thermocouple, its temperature measurement range is 0 to 1500 degrees centigrade. For J-type, it is minus 150 to plus 1000 degree centigrade. So correct option is 4. Next question. Arrange the following in decreasing order of their band energy gap. So let us see some points related to this band energy gap. The energy gap between the top of valence band, that is valence band is highest energy state occupied by the electron at absolute zero temperature, and bottom of conduction band. So the conduction band is lowest energy state where electron can move freely and conduct electricity. So the valency band is top of energy state occupied by the highest energy state, and conduction band is lowest energy state. So the difference between these two band gaps is called energy band gap. For conductor, the energy band gap is very small or no gap exists between valency band and conduction band. So this is conductor. There is no energy band gap between conduction band and valency band. So for insulator, so energy band gap is very highest, and for semiconductor, the energy band gap lies between the conductor and semiconductor. For silicon, the energy band gap value for the silicon is 1.1 electron volts. So energy band gap is the distance between top top of the valence band and bottom of the conduction band. So it is 1.1 electron volts. For germanium, it is 0.67. For gallium arsenide, energy band gap is 1.43 electron volts. For diamond, it is 5.5 electron volts. For cadmium telluride, energy band gap is around 1.5 electron volts. For gallium nitride, it is 3.2 electron volts. For zinc oxide, 3.37 electron volts. For indium antimonide, energy band gap is 0.17 electron volts. So zinc oxide is a wide bandgap semiconductor, and narrow bandgap semiconductor is indium antimonide INSB. So ZnO is having wide bandgap and INSB is having narrow bandgap. So from the question, the correct option is D, A, B, C, E. So in the decreasing order, so highest is for D, ZnO, zinc oxide. This highest is for zinc oxide and lowest is for INSB. So highest is for zinc oxide D and lowest is for E. So that is INSB. So for next is silicon, germanium. So germanium, that is C. Next last one is C. Gallium arsenide, silicon, germanium and INSB. The correct option is D. Next question. Identify the following 1, 2, 3 blocks in the block diagram of phase lock loop PLL. In PLL is a feedback control system that automatically adjusts the phase of locally generated signal to match the phase of the input signal. So the definition of PLL is, it is a feedback control system that automatically adjusts the phase of locally generated signal to match the phase of an input signal. So the first block is phase detector or phase comparator, followed by low pass filter, and block 3 is voltage controlled oscillator, and the feedback is provided. V in is the input and V out is the output. So the correct option is 2. Block A is phase detector, so this is 1. So phase detector, and 2 is low pass filter, and 3 is voltage controlled oscillator. A, C and B. Next, for the 8051 microcontroller, during its operation in serial mode 2, so that is multiprocessor mode. So in multiprocessor mode, for 8051 controller operating in mode 2 transmits 11 bits of data 11 bits of data during serial communication 11 bits of data during serial communication, but the last bit is discarded. In mode 2 operation, last bit is discarded. The first 10 bits of data are considered for actual communication between the multiple processors, and 11th bit is serving as a programmable extra bit. Next, mode 0 is synchronous at 1 by 12th of oscillator frequency. Mode 1 and mode 2 are asynchronous modes, but in mode 2, it is 1 by 32 or 1 by 64 of oscillator frequency, and mode 3 is 11 bit asynchronous with variable rates. So 8051 microcontroller, the baud rate in serial data mode 2 is fixed either at 1 by 32 or 1 by 64 of crystal oscillator frequency, depending on the S mod bit in the PN register. Unlike mode 1 and mode 3, where baud rate is determined by timer 1 settings, mode 2 provides a fixed baud rate. So mode 2 have fixed baud rate. Let us see the options. So 11 bits are transmitted. Option A is correct. So the 11th bit is stop bit. Stop bit is discarded. It is not a start bit. So option E is correct. Statement E is correct, and statement D is wrong. And next, and the frequency is 2 power S mod by 32D into timer 1 overflow frequency. So it is the correct option is A, B, and E. So it is not timer 1 oscillator frequency. It is timer 1 overflow frequency, but it is 1 by 32 or 1 by 64 times of crystal oscillator frequency. Here it is mentioned crystal oscillator frequency. So statement B is correct. Statement C is wrong. Statement B is correct. Statement C wrong, and statement E is correct because stop bit is discarded. So this and last bit is discarded. So correct option is A, B, and E. Statement A correct, statement B correct, and statement E correct. Next question. For a QPSK modulator with an input data of 10 Mbps and carrier frequency of, so carrier frequency FC. Let us assume carrier frequency FC and input data rate, that is RB 10 Mbps. The minimum double-sided, so the question they have given, minimum double-sided Nyquist bandwidth and baud rate will be. So symbol rate is the number of symbols transmitted per second. So QPSK encodes 2 bits per symbol. So the baud rate in QPSK is half of bit rate. Half of, so that is bit rate is twice that of baud rate. So baud rate in QPSK is half of bit rate because in QPSK each symbol is encoded, 2 bits are encoded in each symbol. So Nyquist bandwidth is a minimum bandwidth required to transmit the signal without inter-symbol interference. So for QPSK, minimum Nyquist bandwidth is half of symbol rate. So that is half of symbol rate. So symbol rate is 1 by 2 times of bit rate. So that is 1 by 4th of bit rate in case of QPSK. But the formula is minimum Nyquist bandwidth is half of symbol rate. In QPSK, symbol rate is half of bit rate. So that is 1 by 4th of bit rate. So in the question they have given 10 Mbps. So its value is 5 Mbps. Next, minimum double-sided bandwidth is equal to symbol rate. So that is minimum double-sided bandwidth is equal to symbol rate. Minimum double-sided Nyquist bandwidth is symbol rate. So here it is not Mbps, it is hertz. So megahertz. So Nyquist bandwidth is symbol rate. So that is 10 Mbps. So it will become 10 mega. So symbol rate, that is 1 by half of bit rate. Half of bit rate, that is 10 mega, will become 5 megahertz. So bandwidth unit is 5 megahertz, and baud rate is half of symbol rate, half of bit rate, that is 10 Mbps. So it will become 5 Mbps. So that is 5 mega, not bits, it is baud. 5 mega baud. So the correct option is minimum double-sided bandwidth is 5 megahertz, and and the baud rate is 5 megabauds. Correct option is 2. Next question. Which of the following statements are correct when effective mass of electron is taken into consideration? Statement 1. So let us see some points. The negative effective mass of electron accelerates in negative direction. The negative effective mass of electron accelerates in opposite direction of applied electric force. In conduction band, electron has strong dependence electron has strong dependence on the band gap. Smaller the band gap, smaller the effective mass. Smaller the band gap, smaller the effective mass. Okay. So first statement, the electron effective mass is independent of semiconductor properties. So it is wrong. So it is purely dependent on semiconductor properties. The effective mass of electron quantifies how electron motion in a crystal lattice deviates from that of free electron. Effective mass varies depending upon the material, specific energy band, and it is also affected by band structure and interaction of charge carriers with the periodic table. So it is effective mass purely depend upon the semiconductor properties. Statement A is wrong. Next, electrons near to the top of valency band have negative effective mass. Statement B correct. Next, conduction band, electron effective mass has strong dependence on the value of band gap. Correct. The effective mass decreases with band gap increases. It is wrong. So effective gap increases as a band gap increases. Effective mass, if effective mass gets decreased, then band gap if band gap is decreased, effective mass also decrease. If band gap increases, then effective mass also increases. Next question. So given the block diagram reduction is given. So the first statement or first one is moving a shifting point or takeoff point before the block. So it is related to moving a shifting point, or this shifting point has to be moved to this position. In this case, this third, for option A, matching is third one. Shifting the moving the shifting point before the block, or moving the takeoff point before the block. So A is 3. A is 3. Next, second one, fourth one is this moving the shifting point after the block. Moving the shifting point after the or moving the takeoff point or shifting point beyond the block or after the block. So for this, for option D, the correct one is 2. For option D, the correct statement is matching statement is 2. Next, statement B is there are two parallel blocks. So forward path here, similarly forward path also here. These are two parallel paths. So combining blocks in parallel or eliminating the forward loop. There are two forward loops and we have to eliminate the one forward loop. Combining blocks in parallel or eliminating forward loop. Next, statement 3 is this is forward path and this is feedback path. So this is a feedback control system. The correct option is D. G by 1 plus G of S by 1 plus open loop by 1 plus open loop multiplied with closed loop. G by 1 plus GH. So for C it is 4. So that is eliminating the feedback loop. So correct option is 2. Next question. A thyristor having the equivalent capacitance of the depletion layer of a reverse biased junction has 20 picofarad. So given capacitance is 20 picofarad. It is fired with a dV by dt of 120 volts per microsecond. Volts per microsecond. Then capacitive current. We know that capacitive current IC is C dV by dt. So that is 20 pico is 10 power minus 12 into 120 micro, that is 10 power minus 6. 240 into 10 power minus 6. 2400 into 10 power minus 6. It is 2.4 milliamperes. So correct option is 2. 2.4 milliamperes. The capacitive current flowing through the junction. So IC is the capacitive current flowing through the junction. Next question. For an infinitesimal electric dipole dissipated as shown in the figure. So there are two opposite charges, plus equal and opposite charges, plus q and minus q, separated by a distance of l or separated by a distance of d, whatever it may be. R is a radius from the center of dipole to the point P. R is a distance from the center of dipole to the point P. R1 is a distance from positive charge to the point P. R2 is a distance from negative charge to point P. Next, the infinitesimal dipole or Hertzian dipole is an ideal dipole, is a very short thin wire. The electric potential at a point P which is far away from the dipole is Q by, it is given as potential V is equal to Q by 4 pi epsilon naught d by r square, d by r square into cos theta. So where d is a distance between positive and negative charge, r is a, this r is a distance from the center of infinitesimal dipole or Hertzian dipole to a point P. So this is a point P. So potential V is given as Q by 4 pi epsilon naught d by r square into cos theta. We know that electric field and potential as related as E is equal to minus del V, gradient of potential. So that is 1 by 4 pi epsilon naught P by r cube, 1 by 4 pi epsilon naught d by r cube into 2 cos theta ar cap sin theta a theta cap. So in this case, potential is 1 by 4 pi epsilon naught d by r square into cos theta. So statement A is correct, and potential at a point P, statement C is correct. So in this electric field equation, the field component in phi direction is 0. So the field exists, electric field exists only in radial component as well as in theta direction, but in the phase component, E phi component is 0. E phi component of electric field is 0. So the correct option is A and C. Correct option is A and C, that is, sorry, correct statements are A and C. Option 2 is correct. Next, when a plane electromagnetic wave from medium 1 having permittivity of epsilon 1 is incident normally on the surface of perfect dielectric. So it is perfect dielectric of medium 2 with permittivity of epsilon 2. Then what is the relationship of electric field strength for a reflected wave to the electric field strength of the incident wave? So in the, so relation between reflected wave to incident wave. So this reflected component of electric field and incident component of electric field is related by voltage reflection coefficient. So this reflection coefficient gamma is given as ER naught by EI naught. So that is eta 2 minus eta 1 by eta 2 plus eta 1. So where eta is intrinsic impedance of medium. So eta 1 is intrinsic impedance of medium 1 and eta 2 is the intrinsic impedance of medium 2. So the relation between intrinsic impedance and mu epsilon is given by intrinsic impedance is given by square root of mu epsilon. So in the question they have given the permeability of the both mediums are same. So that is mu1 is equal to mu2 is same. So the permeability is same, but only permittivity will change. So now eta 1 is square root of mu by epsilon 1 as per the question, and eta 2 is square root of mu by epsilon 2. Substitute eta 1 and eta 2 in this reflection coefficient equation. So then we will get reflection coefficient gamma is square root of epsilon 1 minus square root of epsilon 2 by square root of epsilon 1 plus square root of epsilon 2. This is reflection coefficient gamma. So the correct option is 4. Similarly, the transmission coefficient is defined as the ratio of transmitted electric field to incident electric field, and the transmission coefficient is given as eta naught by transmitted ratio of transmitted component to incident component, that is 2 times of intrinsic impedance in medium 2 by, eta 1 plus eta 2. Eta 1 is intrinsic impedance in medium 1 and intrinsic impedance in medium 2. So that is transmission coefficient tau is equal to 1 plus reflection coefficient. Next question. The output of a control system is given as C of t is equal to 1 plus 0.25 e power minus 50t minus 1.25 e power minus 10t. So we know that in Laplace transform of e power minus at is given as 1 by s plus a. Laplace transform of 1 is 1 by s. Given output C of t and input is step input. For Laplace transform of output is, so Laplace transform of C of t is equal to Laplace transform of 1 is 1 by s. Laplace transform of 0.25 e power minus 50t is 0.25 by e power minus 80. Laplace transform is 1 by s plus a. So that is 1 by 0.25 s plus 50 minus 1.25 by s plus 10. So this is the expression for output C of s, and for step input R of s. For step input R of s, it is step signal. Laplace transform of unit step function is 1 by s. Now the transfer function is Laplace transform of output to input. So that is y of s is equal to C of s by R of s. Laplace transform of output to Laplace transform of input. So now we will get the output expression as s plus 50 s plus 10 plus 0.25 s into s plus 10 minus 1.25 s into s plus 50, and the denominator of the transfer function is s plus 50 s plus 10. So that is equal to s square plus 60s plus 500. Now this compare the, now the characteristic equation is denominator of the transfer function. So characteristic equation is s square plus 60s plus 500, that is equal to 0. Compare it with the standard second order form of characteristic equation, s square plus 2 zeta omega ns plus omega n square is 0. So from this omega n is square root of 500, so that is 22.36 radian per second, and 2 zeta n is 2 zeta omega n is 60. So from this zeta is 60 by 2 into 22.36, so its value is 1.341. So 1.341 is a damping ratio and natural frequency is 22.36 radian per second. So correct option is 4. Next question. So BC, so it is related to the thyristor. So we know that triac is triode AC switch, diac is diode AC switch. So this is a symbols for diac and triac. So next is ETO, emitter turn off thyristor. So this emitter turn off thyristor is a type of thyristor that uses MOSFET to turn on and turn off. It combines the advantages of both GTO, gate turn off thyristor, and as well as MOSFET. Next is BCT, bidirectional control thyristor. So in this BCT, two anti-parallel high power thyristors are integrated on same silicon wafer with separate gate contacts. So this is BCT, and the equivalent symbol for RCT, reverse conducting thyristor, is there. So this is a symbol for RCT, and different thyristor symbols are represented in this image. So now the question is, so for BCT, so the symbol is 3. This is a symbol for BCT. So bidirectional control thyristor, symbol for BCT. Next, RCT, reverse controlled thyristor. So correct option is 4, thyristor with built-in anti-parallel diode. Next is ETO. So correct option is 2. So turn on and turn off. It can has both turn on and turn off capabilities. Next is triac. So triac is normally operated in two quadrants, that is quadrant 1 and quadrant 3. So these are the thyristor characteristics only in quadrant 1. So triac characteristics quadrant 1 and quadrant 3. So from the characteristics of triac, so normally operated in quadrant 1 and quadrant 3. In quadrant 1, positive gate voltage and gate current. In quadrant 3, negative gate voltage and negative gate current. So for D, it is 1. Matching is 1. Now the correct option is 4. So for A it is 3, B it is 4, C it is 2, and D it is 1. Next question. So given series RLC circuit and they asked to calculate the, and for this series RLC circuit we need to give the block diagram, signal flow graph. So for one signal flow graph is given, we can calculate the transfer function for the signal flow graph using Mason's gain formula. The Mason's gain formula is to obtain the overall transfer function, that is T is equal to sigma I is equal to 1 to k pi delta I by delta, where pk is the gain of, or pi, where pi is a gain of ith forward path, and delta is 1 minus sum of all loop gains of individual loop plus sum of all loop gain product of all possible combination of two non-touching loops plus sum of loop gains product of all possible combinations of three non-touching loops, and so on, where delta I is the value of delta for the part of graph touching ith forward path. Here the variable I we have taken, so it is ith forward path. Next, so for this series RLC circuit, so just consider option 3. So for this option 3, number of forward paths is 1, so this is a forward path, and number of non-touching loops is only one loop, this is one loop. Number of forward paths, so consider option 3. Here number of forward paths is 1, and the gain of forward path is gain of forward path, so it is 1 by SC. So this is again 1 by R plus SL multiplied with 1 by SC, and the number of non-touching loops is 1. The gain of non-touching loop is L1 is equal to minus 1 by SC R plus SL. So apply Mason's gain formula, then we will get the overall transfer function T is equal to P1 delta 1. This is a forward path 1 gain and forward loop gain, so that is loop gain L1, so P1 delta 1 by delta. So here delta 1 is 1. So on calculation P1 delta 1 and delta, the value of delta is 1 minus sum of loop gains of all individual loops, so that is P1 delta 1 by delta, that is P1 is 1 by SC R plus SL into delta 1 is 1, and the value of delta is 1 minus of minus, that is 1 plus R plus SL into SC. So on calculation we will get 1 by R plus SL into SC plus 1. So this is a transfer function. Now E naught of S by EI of S. E naught of S, this is E naught of S by EI of S. So transfer function is E naught of S by EI of S. So E naught of S is, so from this diagram E naught of S is 1 by SC into I of S, and EI of S is E naught of S is 1 by SC into I of S. EI of S is from the given series RLC circuit, so that is R plus SL plus 1 by SC into I of S, current I of S. So again from this E naught of S by EI of S, output by input, so that is transfer function, so will result the same expression. Now the transfer function of this circuit and transfer function of third option 3 signal flow graph both are same, hence the correct option is 3. Next question. Find I naught and I for the circuit using superposition theorem. So superposition theorem states that in any linear bilateral network having multiple independent sources, the response of an element is equal to the algebraic sum of responses of that element by considering one source at a time. Now there are two sources in the circuit, that is 6 volts independent voltage source and 1 ampere independent current source. Let us see the response due to voltage source only when voltage source is acting alone. So the when voltage sources is acting alone, rest all the independent current sources are open circuited and voltage sources are short circuited, and we need to keep dependent sources as it is. Now voltage source is acting alone. In this case, let I naught be the, here they have given I naught and I are the currents. When voltage sources is acting alone, it will be represented with I naught dash and I1 dash. So this I naught dash is written and I1 dash both are equal. I naught dash is equal to I dash. Since this is open circuit, there is no flow of current here. No flow of current here. Entire current will flow in this direction. Next, I naught dash is written as 6 minus 2 I naught by 6. So from this, I naught dash is equal to 6 by 8, that is 3 by 4, 0.75 ampere. Next, see the response due to only current source. So case 1 is response due to the voltage source. So when response due to voltage source, this current source is open circuited. Next case, response due to the current source. In this case, independent voltage source is short circuited. So case 2 is response due to current source only, 1 ampere current source only. So 1 ampere current source is working, then independent voltage sources are short circuited. So in this case, this is a equivalent circuit diagram. Let V be the voltage at this point, that is node A. So in this case, I naught double dash, I1 dash or I double dash are the currents flowing. So apply KCL at node 1. So that is 1 plus I naught double dash is equal to V1 minus 2 I naught double dash by 4. So we know that voltage V. So voltage V is minus 2 I naught double dash, and the resistance here it is 4 ohms, and this resistance is 2 ohms. So now, so from this I naught double dash is minus 1 by 2, that is minus 0.5 ampere. So we know that V is minus 2 I naught. So this is voltage V is equal to minus 2 I naught double dash. So keep this expression in this. So we will get I naught double dash value is minus 0.5 ampere. Now I naught double dash is 0.5 ampere. So from this I double dash is 1 plus I naught double dash. So it is 1 minus 0.5 ampere. So it is 0.5 ampere. Now I is the total current I naught in the circuit is I naught dash plus I naught double dash. The total current I is I dash plus I double dash. So I naught dash is, so total current I is I naught dash 0.75 ampere minus I double dash is minus 0.5 ampere. So minus 0.5 ampere. So total current I naught is 0.25 ampere. Similarly, total current I is 0.75 plus 0.5. So that is 1.25 ampere. So I naught is 0.25 ampere, I is 1.25 ampere. So the correct option is 2. Next question. So this is a theory related to the superposition theorem. Voltage sources are open circuited, current sources are short circuited, and independent dependent sources are active all the times. Next question. Arrange the following antennas on the basis of increasing order of directivity. So directivity of antenna is defined as the ratio of radiation intensity in given direction from an antenna to radiation intensity over all averaged over all directions. For a short dipole antenna, so the directivity is 1.5. For lambda by 4 monopole antenna, so directivity is 3.28. For lambda by 2 monopole antenna, directivity is 6.8. For lambda by 2 dipole antenna, directivity is 1.64 or 2.15 dB. For isotropic antenna, directivity is 1. And for hemispherical antenna, so hemispherical antenna radiates energy in half of the sphere. So isotropic antenna radiates energy in all directions, whereas hemispherical antenna radiates only in half of the sphere. So its directivity is 2 times. So directivity definition is it is a measure of degree to which the radiation emitted is concentrated in a single direction, or measure of how directional an antenna radiation pattern is. So from this the correct option is C. The correct option is C. So in increasing order. So least is for isotropic antenna, that is 1. Next is short dipole 1.5. Next is hemispherical radiator, the directivity is 2. Then lambda by 4 monopole, that is 3.28, and lambda by 2 monopole, that is 6.8. So correct option is 3. Highest is for lambda by 2 monopole and lowest is for isotropic radiator.